Another kind of pattern that you've probably analyzed are correlations. There's a lot that can be done with correlations as well. And let me tell you a couple of examples from the same sectors that we were looking at, education and restaurants. Can we look at the correlation of marks across different subjects? It turns out that there's an 89% correlation between physics and chemistry. Meaning, somebody who scores high in physics has a pretty strong chance that they'll score high in chemistry. Pretty high between physics and biology as well. Chemistry and biology is as high. Mathematics slightly lower, but you can't really tell the difference. Computer science, pretty close. It almost looks like physics, chemistry, biology, mathematics, and computer science, the sciences, fall into a cluster. You do well in one, you'll do well in all the others. But let's take history, economics, commerce, accountancy, to a certain extent botany, zoology, and to a good extent English and languages. You do well in one. The odds that you'll do well in another are not so high. Only a 0.57 correlation between history and English. Only a 0.62 correlation between English and botany. Only a 0.63 correlation between history and accountancy. So it almost looks like if you pick the sciences, you'll either do really well or you'll do really poorly. But if you don't and pick the non-sciences, then it's unlikely that you'll crack it, but it's unlikely that you'll completely mess it up. Which gives people a strategy for how to pick. But it also tells us that there's probably something common in the sciences, which is not as common or as strongly common in the other subjects. Let's apply correlations to restaurants. We were looking at what items are sold together. So, for example, how often do side dishes sell with meals? How often do beverages sell with tiffins? We found that there's a 96% correlation between beverages, tea, coffee, etc., and tiffins, dosa, idli, and so on. But only a 4% correlation between tiffin and breads, roti, naan, etc. That's practically zero. So either people order breads or they order tiffins or they do that independently. Now, if you look at this, you'll find that starters are negatively correlated with almost every item, but desserts are positively correlated with every item. The latter you can understand, right? No, doesn't matter what you have, you typically want to have desserts at the end. So these are positively correlated with practically every item. But one item that is almost negatively correlated with every item is starters. And this was a surprise to the restaurant. They said, why is it that starters are not increasing the sales of other products? They said, we actually introduced starters as a major product category 4 years ago. And our idea was to have such a wide variety of starters at such a good price that people will come in and have our starters, will come in for our starters. And then they will have the rest of the dishes. So starters were a loss leader. That is, they were going to make a loss, but they are what are going to get people in. But when they saw this, they realized what people are doing is ordering starters with breads and then having desserts and leaving. They weren't having any of the main courses that were the actual margin earners, which was a bit of a surprise. Again, one of those situations where people were looking at this day in and day out, but it wasn't obvious to them. In fact, something even more surprising came up when they looked at the individual product correlations. What is the correlation of, let's say, tea with, for example, let's take something that's close by, rava dosa with pav bhaji, 62%, which is moderate. But pav bhaji with idli vada, minus 14%. So maybe it's North Indian, South Indian split. You either have pav bhaji or you have idli vada, but you don't have both. But one of the things that is negatively correlated with almost everything is the 1 liter mineral water bottle. People who buy the 1 liter mineral water bottle don't buy or buy a whole lot less of everything else. Initially, it was a surprise to them, but then they slowly worked it out. They figured the more water somebody consumes at the restaurant, the less space they have for anything else. And they made a very smart. They said, no more 1 liter bottles, only 200 ml. Instant shift in what the performance was. All of these are examples of just correlations, all the three that we saw. And so far, we've looked at 3 techniques. Histograms, you just count stuff. Second, pivot tables, you count stuff but on 2 axes. Correlations, where you calculate how much one variable changes when another variable changes. And just with this, we get a whole bunch of interesting insights. But what I'd invite you to do before going on to the second half of the talk is for you to play around with data. Personally, I find that there are 2 kinds of data that you can generally play around with. One is personal data that you have, that you generate. The other is public data, which you can get from anywhere. For example, take your watch or phone, wherever you track the number of steps. For example, on my phone, I can export the total number of steps that I take every single day. It automatically records it. When do you walk the most? How is that different from your friends? Export it in Excel, play around with it. Or export your calls or messages. When do you call people the most? When do people reply the most? How is that different from others? Which of your friends are early morning repliers? Which of your friends are late night repliers? Look at your wake time, look at your sleep time. How often does this change on weekends? And how does that differ? Is the difference between weekday versus weekend wake up time half an hour, 1 hour, 2 hours, 0? Whose is the highest? Whose is the lowest? These are all examples of data that you generate yourself. You can analyze instantly. That apart, there's public data. For example, the Internet Movie Database has data that you can use to analyze which languages are popular in which region. You may be surprised that, for example, the most popular language in a given country may not be a popular language of movies may not necessarily be the country's national language. It could be something else. And you may find that some movies, generally the movies that have high ratings are popular, but some movies that have a really high rating may not be popular at all. Some movies that have a really high popularity may not have a high rating at all. Which are those? Worth exploring. Or there's this really interesting data set of all the Harry Potter characters that has all the demographic data of the Harry Potter characters. Among other things, it has their hair color and their house, Slytherin, Gryffindor, etc. Is there a bias? Can you create a pivot table that shows by hair color, by Hogwarts house? Is there a concentration of people with certain hair color in a Hogwarts house? Is there a bias? Or currency data. So when one particular currency goes up, does another currency go up along with it or go down? So can we actually see if there are currency clusters that tend to work together with each other, currencies that tend to be bought or sold with each other? Data is there everywhere. And one of the most powerful ways of exploring understanding data is by playing with it. But this is the first part of what we wanted to talk about. The second part is the emotional side. And I'm sure you have several questions on this, but what we'll do is take up this part and then come back to the questions at the end. So with that, Devrani, I'll hand it over to you to talk about data humanism, which is a completely new field, and I'm sure you'll love it. Over to you, Devrani.
Thanks, Anand.